The Earthkind premise focuses on the use of research-proven gardening and landscape techniques to provide maximum plant enjoyment while protecting our fragile environment. Putting Earthkind techniques into everyday practice will help families, businesses, and the community preserve and protect the environment. Healthy landscapes constitute small-scale ecosystems and support many types of organisms, including those that feed on plants. When conditions are favorable for insect reproduction, their populations may increase and reach pest status. When this happens, how should we attempt to gain control? The answer lies in designing and following a pest management plan to reduce the chances for pest outbreaks, detect initial infestations before they cause damage, and use the most appropriate pest control tactics. A pest management plan considers the biology of the pest species and all of the environmental factors influencing pest populations. Integrated pest management is the key component of the Earthkind approach. IPM is the management of pest populations using control strategies that maintain pest populations at levels that can be tolerated by humans in terms of their economy, health, and quality of life. Integrated pest management attempts to integrate tactics with the least environmental and health risks while still having a low impact on beneficial and non-target organisms. It involves modifications of cultural practices to put stress on pest populations to eliminate their damage potential. Crape myrtles are very popular landscape plants among southern gardeners due to their beauty and low maintenance requirements. The ideal planting sites for crape myrtles are well-prepared, well-drained soils at locations with full sun exposure and good air circulation. These conditions will ensure the growth of healthy plants. A stress plant is more susceptible to damage by insects and diseases. The major insect pests of crape myrtles in Texas are crape myrtle aphids, Japanese beetles, and primrose flea beetles. A few insects on a plant usually are not enough to cause damage. However, treatment may be necessary to prevent or minimize damage when conditions are favorable for insect reproduction and population increase. Treatment options may include both non-chemical tactics and practices and chemical control tactics. Apply insecticides only when necessary after all other options are considered, and wherever possible, select the least toxic, most specific insecticide product. Pesticide application should not be the first choice in your plan. The crape myrtle aphid has a narrow host range and is the only aphid species that feeds on crape myrtles. Crape myrtle aphid adults and nymphs are pale yellow-green with black spots on their abdomens and range from 1/16 to 1/8 inch in length. Crape myrtle aphids are found from May through September with peak populations during July and early August. These aphids generally feed on the underside of crape myrtle leaves. They feed by inserting their needle-like mouthparts into the soft tissue and extracting plant sap. As aphids feed, they inject saliva into the leaf tissue, which causes yellow leaf spots to develop. Heavy infestations can deform leaves and stunt new growth. Buds, branch tips, and flowers can also be damaged by feeding injury. In addition to direct damage, aphids can damage plants indirectly by excreting honeydew, a sugary byproduct of their feeding. Honeydew is a perfect source of food for other insects such as ants, wasps, and flies, and is a good substrate for the growth of sooty mold. Although unsightly, sooty mold itself does not directly harm the crape myrtle. Instead, it shades the leaves from light and interferes with photosynthesis. Under heavy infestation, sooty mold-covered leaves may drop early. Protecting natural enemies may provide control over these aphids. However, when conditions are favorable to the pest, natural enemies may not be able to prevent population outbreaks. Some natural enemies of the crepe myrtle aphid are lady beetles, lacewings, and certain types of flies and fungi. Also, songbirds such as finches, mockingbirds, and woodpeckers feed on these aphids. It is important to keep these birds in your area. Some examples of non-chemical control tactics for crepe myrtle aphids include high-pressure water sprays, hand picking, and removal of infested branches or branch tips. Insecticidal soaps and horticultural oils are among the safest chemical pest control products. They have little to no impact on natural enemy populations and are readily available to homeowners in retail garden stores and home improvement centers. When there is a history of aphid infestations occurring each year, dormant oil treatment is a good option. You'll want to apply it to the trunks and stems late in the winter. The oil will smother the overwintering eggs and kill them. Do not use dormant oil during the summer because it may injure the tender new foliage. Systemic insecticides may be applied as foliar sprays or drenches into the root system. Foliar sprays work on contact with the insect pests and require thorough coverage of all infested tissues. Contact foliar insecticides include a wide range of active ingredients. Systemic insecticides, on the other hand, are taken up by the roots and distributed to the rest of the plant. Insects are exposed to the insecticide when they feed on the foliage or sap of the treated plant. Systemic insecticide products also include several active ingredients. The Japanese beetle was introduced into New Jersey in 1916. It spread throughout the eastern U.S. and then into the southern states. It is 1/3 to 1/2 inch in length and oval in shape. Its wings are coppery in color with fine longitudinal lines, and its body is a beautiful metallic green. It has 5 tufts of white hairs projecting from under the front wing on each side and 2 patches of white hairs at the tip of the abdomen. Both adults and larvae of the Japanese beetle can damage the crepe myrtle. The larvae live underground where they usually feed on roots of grasses but may consume young crepe myrtle roots. The adults prefer to eat the tissue between leaf veins, causing a lace-like appearance. Adults are most active during the warmest part of the day, and they are usually found on crepe myrtles that are in full sun. Natural enemies may help to keep Japanese beetle populations at low levels. Natural enemies of this beetle species include wheel bugs, robber flies, and praying mantis. Birds like crows, starlings, song sparrows, robins, and grackles also feed on Japanese beetle adults, so you want these visitors in your area. Neem oil from the neem tree and rotenone are some examples of organic insecticides that can be used to control Japanese beetles. Other chemical, foliar, and systemic insecticidal products contain active ingredients which are effective in controlling these plant pests. The Primrose Flea Beetle is 1/4 inch in length, oval in shape, and shiny blue-green in color. These beetles have an enlarged 3rd pair of legs that are used for jumping, hence the name flea beetle. All of the immature life stages of a flea beetle occur underground. Only the adults are seen by gardeners. The adult beetles lay their eggs and the larvae feed on the roots of primroses. However, the larvae can feed on the foliage or tunnel into the plant stems. Adults feed on crepe myrtles, evening primrose, and other plants. The adult beetles will chew many holes or pits into the leaves, creating a shot hole appearance. The effect of their feeding is most severe when they attack growing tips. Primrose flea beetle feeding limits the ability of the plant to compensate for damage, making young plants and seedlings particularly susceptible. Feeding on seedlings may result in reduced growth and even plant death. Some of the non-chemical control tactics available against the Primrose Flea Beetle include hand-picking and weed control in and around planting sites to remove food resources for developing larvae. Also, preserving natural enemies such as big-eyed bugs, green lacewing larvae, damsel bug larvae, and field cricket larvae will help to keep populations under control. Neem oil and rotenone are again examples of active ingredients found in organic insecticides which are effective against the Primrose Flea Beetle. Several synthetic insecticides are also labeled for use on this plant pest. In summary, the earth-kind approach to pest management integrates plant health and pest control tactics and considers the biology and all the environmental factors that influence pest populations. It starts with accurate pest species identification and using good information when making pest management decisions. This approach may take some time and effort to implement. Remain positive and be patient. In the end, the reward of looking at